Jai Hind everyone. Myself Mani Dublish, Assistant Professor in Akgec Engineering College and MC Department. Today I am going to deliver a lecture on set theory, which is a part of discrete mathematics. So, what is set theory? So, basically, set is an unordered collection of objects called number of element or member of element in the set. So, a set is called set to contain its element, where we can say, if we have mentioned a set 1, 2, 3, 4, 5. So, this is how we represent a set A. So, if I mention, this is a set of all numeric number. If I mention A, B, C, D, up to and so on. So, this is a finite set A in which we have element A, B, C, D, 4 element, and A belongs to set A to denote that A is an element of set A. So, the notation, if I say set A, so I will write A belongs to A. This is how we represent the element of set A in set element. So, the element A, which is belongs to A, denotes that A is a set of A is element of set A. If I here mention E, so and E does not E is not a member of set A. So here I write E does not belong to A. Here there is a mistake. The notation A belongs to A denote that A is an element of the set A. Next, set description. We can describe set in two ways. First one is roster method and second one is set builder method. If I say two sets are equal if and only if they have same element. So, therefore, if A and B are set, then A and B are equal if and only if for X belongs to A and X belongs to B. What does that mean? I have write two sets are equal if and only if they have the same element. Means set A I have an element set of A are 1, 2, 3, 4. Next set I have taken B. Again here I have set 1, 2, 3, 4. So, what can I say? A is equals to B. Means set A belongs to set A and set B both are equal because set A belongs to element 1, 2, 3, 4 and set B belongs to element 1, 2, 3, 4. The member of element of A and B both are same. Then we can say A is equals to B means A and B both are equal set. This is the definition of equal set. If the element of both sets are equal, then when we can say that both set are equal set. Next, Venn diagram. So, we can represent set graphically by using Venn diagram. So, in Venn diagram, the universal set U, which contains all the objects under consideration, is represented by the rectangle. Inside the rectangle, circle or other geometrical figure are used to represent set. So, point are used to represent a particular element of the set. So, Venn diagram are used to indicate the relationship between set. The set A is a subset of B if and only if every element of A is also an element of B. Let's understand with the help of the example. I have explained the set A is a subset of B. This is the symbol of subset. The set A is a subset of B if and only if every element of A is an element of B. If this condition is true, then we can say A is a subset of B. Set A, we have two set A and B. In set A, we have element 1, 2, 3. In set B, we have element 1, 2, 3, 4, 5. 1, 2, 3, which are the element of A, belongs to B. Then we can say A is a subset of B. Now, finite set. Let S be a set if there are exactly n distinct elements in S where n is a non-negative integer, then S is a finite set. And n is the cardinality of S. The cardinality of S is denoted by symbol, and a set is said to be infinite if it is not finite. Given a set S and the power set of S is the set of all subset of the set S, so the power set of S is denoted by PS, where P denote the power. The ordered n tuple A1, A2, An is the ordered collection that has A1 as its first element and A2 as its second element and A as its an element. So, this is the ordered tuple, and the Cartesian product, if we have two set A and B, the Cartesian product of A and B denoted by A cross B is the set of all ordered pair AB, where A belongs to A and B belongs to B. So, we can write A belongs to A, B belongs to B. We can write A cross B is equals to A Cartesian AB, where A belongs to A intersection B and B belongs to B. So, this is how we represent Cartesian product. Now, set notation with the help of quantifier. Sometimes we restrict the domain of a quantified statement explicitly by making use of a particular notation. So, universal for all x belongs to x, Px denote the universal quantification of Px overall element in the set X. In other words, for all x belongs to S, Px is shorthand for all x belongs to x implies that Px. And essential quantifier means for exists x belongs to S, Px denotes the essential quantification of Px overall element in X, that is for all x there exists x that is belongs to S, Px is in short we can write there exists x where x belongs to S and Px. Now, the set operation we have, suppose we have two set A and B. So, the union of set A belongs to the union of set A and set A and B denoted by A union B is the set that contains those elements that are either in A or in B or in both. That is known as A union B. Suppose we have set A 1, 2, 3 and we have write 3, 4, 5 and we have to create A union B, then we can say 1, 2, 3, 4, 5. So, this is how we create union of two set. Now, intersection. So, the let A and B be two sets. So, the intersection of set A and B denoted by A intersection B. Suppose, again I am taking an example, A is equals to 1, 2, 3 and B is equals to 3, 4, 5. So, A intersection B is equals to 3. This is how we represent intersection set. Next one is disjoint set. Two sets are called disjoint if their intersection is empty set. A 1, 2, 3, B 4, 5, C 6. Disjoint A intersection B null because no any element is common. So, A intersection B is disjoint set. So, these are the basic set operation which we generally used in our set theory: union, intersection and disjoint set. Next, let A and B be two set. The difference of A and B denoted by A minus B is the set containing those elements that are in A but in B. So the difference of A and B is called the complement of B with respect to A. Let's take an example. A 1 2 3. So A minus B is the set containing those elements that are in A but not in B. That are in A but not in B. So answer would be 1 2 3 would be the answer. Next, let U be the universal set. The complement of the set A denoted by A is the complement of A with respect to U. Therefore, the complement of the set A is the union minus A. Means we have a universal set. Suppose I have taken element in universal set 1 2 3 4 denoted by, let U be the universal set. The complement of A we have to find out, and A is equals to 4 5 6. So A complement is equals to union minus A. Let U be the universal set. The complement of the set A denoted by A is the complement of A with respect to U. Therefore, the complement of the set is U minus A. 1 2 3 4 4 5 6. A is the complement of set A. Now we have studied 4 basic operation. First one is union, intersection, disjoint, difference, and universal set. So these are the basic and useful set operation which we going to use in next topics of discrete mathematics. Now, these are the some important and basic law by which we can solve the identity problem. First one is identity law. Identity law means A intersection union is equals to A. A union phi is equals to A. This is the identity law. Next one is domination law. Domination law means A union with the set of universal set is equals to universal set, or A intersection phi is equals to phi. This is the dominant law. Next one is idempotent law. Idempotent law means A union A is equals to A और A इंटरसेक्शन A is equals to A. हम किसी भी एलिमेंट का किसी के साथ भी उसी सेम एलिमेंट के साथ अगर हम उसका यूनियन निकालें चाहे इंटरसेक्शन निकालें, अगर वो सेम एलिमेंट ही निकल के आता है तो हमारा A आइडेम्पोटेंट लॉ कहलाता है. कॉम्प्लीमेंशन लॉ क्या होता है? A कॉम्प्लीमेंट का कॉम्प्लीमेंट इज इक्वल्स टू A. मीन्स कॉम्प्लीमेंट से कॉम्प्लीमेंट अगर कटिए तो वो क्या बनेगा आपका कॉम्प्लीमेंशन लॉ. कम्यूटेटिव लॉ क्या होता है? A यूनियन B इज इक्वल्स टू B यूनियन A, या फिर हम बोले A इंटरसेक्शन B इज इक्वल्स टू B इंटरसेक्शन A. मीन्स कम्यूटेटिव लॉ की जो प्रॉपर्टी है वो इन द केस ऑफ एडिशन और इन द केस ऑफ मल्टीप्लिकेशन दोनों केस में आपकी कम्यूटेटिव प्रॉपर्टी सेटिस्फाइड होती है. एसोसिएटिव लॉ की प्रॉपर्टी क्या होती है? A यूनियन B इंटरसेक्शन C, सॉरी A यूनियन B यूनियन C इज इक्वल्स टू क्या होगा आपका? A यूनियन B यूनियन A यूनियन B यूनियन C इज इक्वल्स टू A यूनियन B यूनियन C. नेक्स्ट वन A इंटरसेक्शन B इंटरसेक्शन C इज इक्वल्स टू A इंटरसेक्शन B intersection C. This is the property of associative law. The most important law is distributive law. Distributive law, A union B intersection C. Now understand how we apply distributive law. बाहर वाला एलिमेंट किसके साथ आप डिस्ट्रीब्यूट कर दो? अंदर वाले दोनों एलिमेंट के साथ. बाहर वाले दोनों चीज इन दोनों एलिमेंट के साथ आपको डिस्ट्रीब्यूट करना है. तो हम क्या लिखेंगे? A union B. बाहर वाला अंदर वालों के साथ, ए यूनियन सी, और ब्रैकेट कौन सा लगेगा आपका, ए यूनियन बी इंटरसेक्शन सी इज इक्वल्स टू ए यूनियन बी इंटरसेक्शन ए यूनियन सी। नेक्स्ट एलिमेंट क्या हो सकता है आपका, ए इंटरसेक्शन बी यूनियन सी। अगेन इसको दोनों के साथ डिस्ट्रीब्यूट करना है, ए इंटरसेक्शन बी और ए इंटरसेक्शन सी, किसका आया, बीच में ऑपरेशन यूनियन का। सो दिस इज हाउ वी अप्लाई डिस्ट्रीब्यूटिव लॉ। नेक्स्ट वन इज इंपॉर्टेंट है आपका हमारा डिमॉर्गन लॉ। डिमॉर्गन लॉ क्या होता है हमारा, ए यूनियन बी का कॉम्प्लीमेंट, ए यूनियन बी का कॉम्प्लीमेंट। अब इस कॉम्प्लीमेंट को हम बाहर लेके चलेंगे तो हम कैसे लिखेंगे इसे, ए यूनियन बी का कॉम्प्लीमेंट इज इक्वल्स टू क्या होगा हमारा, ए कॉम्प्लीमेंट यूनियन का क्या हो जाएगा उल्टा, यानी कि बी कॉम्प्लीमेंट। यानी क्या बने हमारा, ए यूनियन बी का होल कॉम्प्लीमेंट इज इक्वल्स टू क्या होगा, ए कॉम्प्लीमेंट इंटरसेक्शन बी कॉम्प्लीमेंट। नेक्स्ट वन क्या होगा, ये वाला ए इंटरसेक्शन बी का कॉम्प्लीमेंट इज इक्वल्स टू ए कॉम्प्लीमेंट यूनियन बी कॉम्प्लीमेंट। दिस इज द फॉर्मूला ऑफ डी मॉर्गन लॉ। नेक्स्ट वन एब्जॉर्प्शन लॉ। एब्जॉर्प्शन लॉ क्या होता है हमारा, ए यूनियन ए इंटरसेक्शन बी इज इक्वल्स टू ए यूनियन ए इंटरसेक्शन बी निकल के अगर वही एलिमेंट आ रहा है तो वो क्या होगा हमारा, एब्जॉर्प्शन लॉ होगा। दूसरे केस में क्या हो सकता है आपका, ए इंटरसेक्शन ए यूनियन बी, अगेन क्या कितना होगा हमारा ए। दिस इज द एब्जॉर्प्शन लॉ। लास्ट कॉम्प्लीमेंट लॉ। कॉम्प्लीमेंट लॉ क्या होता है हमारा, ए यूनियन ए कॉम्प्लीमेंट ऑलवेज द यूनिवर्सल सेट, और ए इंटरसेक्शन ए कॉम्प्लीमेंट इज इक्वल्स टू 5। So these are the set identify which we can directly use in the questions. Now, what are the multiset? So multisets are the unordered collection of element where an element can occur as a member more than once. मीन्स अगर आपका सेम एलिमेंट है एक से ज्यादा बार आपकी उसकी फ्रिक्वेंसी आ रही है किसी कलेक्शन ऑफ एलिमेंट के अंदर, देन वी कैन से दिस इज द मल्टीसेट। सो the notation m1 dot a1 m2 dot a2 up to and so on, last element mr dot ar denotes the multiset with the element a1 occurring m1 times, so element a2 occurring m2 times and so on. Means here I have read m1 dot a1 comma, we can mention m2 dot m2 dot a1 m2 dot a3. So occurrence of a1 frequency of a1 occurring m1 times, or the element a2 occurring m2 times, so and so on. So this is the definition of multi-ordered set, ki where an element can occur as a member more than once. So this is the property of multiset. So now the number mi where I is equals to 1, 2 belongs to R, or called the multiplicity of the element ai, such that I belongs to 1, 2, R, that's all. So this is that's enough from today's class. In next lecture I will cover K maps. So thanks, that's Jai Hind.